Hiya folks, in this video we're just going to have a look at a simple calculation involving capacitors. So in this question we have a 6 millifarad capacitor is connected in parallel with a 3 millifarad capacitor. The combination is connected across a 30 volt supply. We're being asked to calculate the voltage across each capacitor, the charge stored in each capacitor and the capacitance of that combination. So starting point for any question like this would be to sketch out a diagram just to help you visualize what is going on. So we have a 6 millifarad capacitor. In parallel across that, we have another capacitor with a value of 3 millifarads, and that combination is connected across a 30 volt supply. So just going to use the symbol for a cell here and we'll label that as 30 volts. So part A of the question is asking what is the voltage across each capacitor? Well, actually we don't need to do any calculations here. What we need to make use of is what do we know about how voltage behaves in series and in parallel. In parallel we know that the voltage is always the same. So across both of those capacitors, the voltage is 30 volts each. Okay, part B, the charge stored on each capacitor. So let's begin with the equation that we have for capacitance, which is C is equal to Q over V. And that comes from the definition of capacitance. The capacitance is the amount of charge that's stored per volt. So we have Q divided by V. If we rearrange that equation becomes Q is equal to C times V. So let's begin with the 6 millifarad capacitor. Then the capacitance is 6 by 10 to the minus 3. Because of the milli, then we multiply that by the voltage, which is 30, which gives us 0.18, and that's 0.18 coulombs of charge. For the 3 millifarad capacitor, the charge is 0.09 coulombs. And now we want to look at the capacitance of the combination. So for this, again, we've already been told in the question and we've drawn a diagram showing that these capacitors are connected in parallel, and we need to use the appropriate formula then for working out the total capacitance. And when those capacitors are connected in parallel, the total capacitance is the sum of the individual capacitors, which in this case is the 6 millifarad capacitor plus the 3 millifarad capacitor. And that gives us a total then of 9 by 10 to the minus 3 farads, or just 9 millifarads. And that's it, straightforward calculation.